Problem 3-115. Use the graph of f of x equals the absolute value of the quantity of x minus 3 plus 1 in problem 3-114 to solve the equations and inequalities below. It may be helpful to copy the graph onto graph paper first. So in the last problem, you were just using the graph to come up with the answers. You were given an input and you were finding the output. For these problems, for A, we have the absolute value of x minus 3. And we're adding 1 to that, and it says that should equal 1. So if 1 was our output, let's look at, on our graph, remember our outputs are the y values. So we have to look up and down at our graph here to figure out where that output would be. I know this output right here is where 1 is. This is our y value when it's 1. It's all the points on this line. And right here is where our actual graph has an output of 1. So what is our x value here? Our x value would be 1, 2, 3. So I'm going to bet here that when we solve this algebraically, we should end up with x equaling 3. It's kind of our guess here. We'll kind of throw it over here. We're going to say x equals 3. Well, how do we solve this algebraically? First thing we want to do when we're solving an absolute value equation here is we want to try to get our absolute value by itself. That means you're treating it almost like it's a big variable. If I replaced my absolute value of x minus 3, if I replaced it with a y, and I said y plus 1 equals 1, and I asked you to solve this for y, to get y by itself, you would subtract 1 from each side. We're going to do the same thing here. I'm going to go ahead and subtract 1, and I'm simply bringing down my x minus 3 in my absolute value brackets, and that should equal 0. Now let's kind of think about common sense here. We know absolute value is the distance a number is from 0. So if I was trying to plug in some number in here, what number is 0 units from 0? Well, there is only 1 there, right? That number would have to be 0 in here. So whatever we have inside of our absolute value bracket has to end up equaling 0. So if we think about, we have this expression here, x minus 3, and it has to equal 0. So let's go ahead and set it equal to 0. X minus 3 equals 0. Solve it for x, and we get x equals 3. Well, we predicted that x would equal 3 because when we take 3 and we plug it into our equation here, plug in our input, our output should be 1, and that's what we had our output be in this problem. So in this letter A, x equals 3. If you're not fully grasping, that's okay. We have some more that we can try here. Let's go ahead and do B. The absolute value of x minus 3 plus 1 is less than or equal to 4. Now on the last problem, we were looking at all the values. We were looking for when the value was exactly 1. Our output was 1. Now we're looking for all the outputs that are going to be less than or equal to 4. Think about our value here. This is where our output is going to be 4 right here. This is where our output's going to be 4. So there's going to be 2 answers where it'll be exactly 4. When x is 0, when x is 6. But then we have to think about all the values that are less than 4. Well, that would include everything all the way down here and all the way up here. So since we're working backwards to kind of find what our inputs would be, we know that our answer should end up being everything from 0 over to 6. But let's look and see how we do that. So we're going to solve this one. We're going to think about it from a similar standpoint. We want to isolate our absolute value brackets there. So we got to get rid of everything that's not attached to it. So we got to get rid of that 1 again. And we should have the absolute value of x minus 3 is less than or equal to 3. Now, many of you learned this in Algebra 1. Some of you may remember it, some of you may not. But this here is going to be a conjunction because we're dealing with an inequality here. And we're looking for values that we're looking for the intersection here of our values. So we think about our boundary points. We said that we're going to have a boundary point at 0, and we're going to have a boundary point at 6. That's where our endpoints are, and we're representing everything in between. So our values here, if we look at, like we did on our problem over here, we're trying to say what values are going to be less than or equal to 3 units. Well, as we go back, if you think about going backwards on a number line, if we're trying to fill in what's less than or equal to 3 units from 0, I'm going to draw a little separate number line here. I got 0, I'm going to put a 3 here, and I'm going to put a negative 3 over here. I want to know what numbers on my number line are less than or equal to 3 units from 0. Well, we know 3 is 3 units from 0, and we know negative 3 is equal to 3 units from 0. But what other numbers would work? Is 4 more than 3 units or less than 3 units from 0? 4 is going to be more, right? We want everything that's less. So we're going to have to represent all of the numbers in between here. So the way we do this is we take what we have here, and we're going to go ahead and rewrite it as x minus 3 has to be less than or equal to 3. That's like an inequality here going this way. And think about inequalities coming from here. What would this inequality be? Well, you're going to say x would be greater than or equal to negative 3. So we have to write a second inequality. X minus 3 has to be greater than or equal to negative 3. And now we could go ahead and we try to solve these. We'll add our 3 to each side here. We get x is less than or equal to 6. And we add our 3 to each side here. And we get x is greater than or equal to 0. Think about what those mean here. Talk about all the values of x that are greater than or equal to 0. That would be starting here and going this way. And all the values that are less than or equal to 6. That would be the values here that are going this way. And we want all the numbers that satisfy both of these. So that would be that overlap here. And it's all these values that we highlighted from the start. So our answer for B is going to be x is less than or equal to 6 and greater than or equal to 0. If you want to write it as one statement, that's what that would be. Or it is completely acceptable to write it as 2 statements, just like this. All right, let's take a peek at another one here. Letter C. We've got the absolute value of x minus 3 plus 1 equals 3. So let's take it now here and let's put another graph in here so we don't have to reuse that same one again. I'll pop it right in there. That looks good. So we're looking for what input value of x is going to give us an output of 3. So when we find 3 here, we're going to have actually a couple places where our graph has points that contain y values that are 3. This would be one of them, and this would be one of them. What is our x value there? Well, our x value is 1 here, and our x value here is 5. So we can kind of go ahead and predict that our answers are going to be 1 and 5, or we know that they're 1 and 5. Let's do it algebraically now. We're going to go ahead here and get our absolute value brackets by itself. So we have absolute value of x minus 3 equals 2. And we have to think about it. What two values are 2 units from 0? What two numbers can I plug in here, though I have to end up with that are 2 units from 0? Well, we know that negative 2 is 2 units from 0. It has an absolute value equal to 2. And positive 2, which means our x minus 3 has to either end up equaling negative 2 or positive 2. So let's just take it here and set it equal to negative 2 and set it equal to positive 2. So remember, we could have a negative 2 in here, or we could have a positive 2 in there. So this has to equal that. Let's go ahead and solve it. You get x equals 1. And I think we predicted that. And we go ahead and add 3 to each side here, and we get x equals 5, which is exactly what we said there. So for letter C, x equals 1, and x equals 5. All right, last one here. We're going to talk about part D. This time we're looking for all the values that are greater than 2. Let's make a little bit more room. So the absolute value of x minus 3 plus 1 is greater than 2. Just go ahead and pull out one more graph here. So now we're looking for all the values in this function that have outputs greater than 2. And let's just go ahead and highlight where those are. Here's where our output is 2. So remember, we don't want to include this. We're just talking about all these values here that are greater than 2. This is where our output, or our y coordinates, are greater than 2, going up this way. This is what we would call a disjunction, because the answer can be over here, or the answer could be over here. Let's follow the same process. Let's isolate the absolute value brackets. Subtract your 1, subtract your 1. So the absolute value of x minus 3 is going to be greater than 1. And if you think about it on a number line again, just thinking separately here from this, we're just thinking about what values would make this true. Well, if we had 0 here, and we were talking about 1 unit away from 0, you have to think about negative 1 and positive 1. Those are each exactly 1 unit from 0. But we're looking for everything that is more than 1 unit from 0. So we can't include these, but we know that all the values to the left of negative 1 are more than 1 unit from 0. And all the values to the right of positive 1 are more than 1 unit from 0. So what is this inequality? Well, this is like saying less than negative 1. And all of these values here are greater than 1. So our values that we end up inside here, this x minus 3, they have to be less than negative 1, or those values of x minus 3 have to be greater than positive 1. take it. Let's go ahead and solve those there. So add your 3 to each side. You should get x is less than 2. Or, and you have to have or in there. It is part of your answer. We add 3 to each side here. We get x is going to be greater than 4. And let's take a peek here and see if that makes sense with our graph. We're saying that on our graph here, all of these points have an output that is greater than 2. Well, where does that start? At 4, we have a value of 2, so it's everything greater than 4, which is what we have. And it's everything less than negative 2. I'm sorry, less than positive 2, which is what we have here. So that is our answer for this problem. X is less than 2, or x is greater than 4. I realize you probably haven't done many of these here. Our book just kind of started throwing them out there at us here in this last section or two, but it is something that you probably have seen in the past. If you haven't, then it's just going to take a little practice here to get the hang of it. Make sure you ask your teacher if you have additional questions. I hope this helped clarify a little bit there. Good luck with this concept there. Keep working hard. Thanks for watching.